Okay, so in 5.1, number 79, they supplied me with two numbers. Those two numbers are 2 to the 2 to the 2 to the 83rd and 3 to the 3 to the 3 to the 52nd. So, what I would like you to try to do is punch these in a calculator quick. I don't know, try it. You just trust everything the math book says?
2 to the
Don't do that.
To the seconds to the 83rd.
Equals buffer overflow.
Yeah.
Cool. One of you guys got a laptop sitting open? Can you Google? So go to Google and type this in. 2 caret 2 caret 2 caret 83. See. It's shift 6. Okay. Yeah.
What are you?
No idea.
Manlove.com.
That's not a good name.
Yeah, no. That's why I stay away from using. Yeah.
Manlove.
Does it give you a number? What does it say?
Snap you,
Gives me a couple videos.
Couple videos.
This is how you figure something. God, instead.
Huh. Google doesn't even try. Lame. Okay, so anyway, I'm supposed to figure out which of these two numbers is bigger, and I can't get like a number out of these, right? The reason I can't get a number out of these is like your calculator has a finite amount of memory. And this has too many digits to fit in your calculator's memory. So you need a bigger calculator, which is why I tried it on a computer, right? I was hoping that Google servers would just crank this out with their, basically infinite capacity, but apparently they don't bother. So,
It needs to be 64 to the 83rd.
oh yeah, so remember this thing is
Or no.
2 to the 2, and it's not then to the 2,
Okay.
right? Because this would be 2 to the 4th. Because I'd multiply the powers. This thing's even worse. This is a tower of powers as opposed to like repeated powering. So the way that I might try to compare these things is I could do some log of logs of them. And that's what the book suggests. They suggest looking at log of A and log of B. So let's see if we can figure that out. So what would log of A be? Log of A. Oops, I know what A is. A is that thing. 2 to the 2 to the 2 to the 83rd. So why was this a good idea? What can you do with the powers? Yeah, drag the powers down to the front, right? Take this whole shebang, drag it out of the first logarithm. So now I'd have log of 2 to the 2 to the 83rd log of 2. You guys with me on that? Those are multiplied, right? You guys with me on that? Okay, so now I have log of some stuff times some stuff, which I can what? Can I log rule that into something? I'd love to, but the 2 and the 83 aren't on both the things there. Right, if I had like 2 times log 2 all to the 2 to the 83rd, then I could pull a 2 to the 83rd down. Right now I've got like log of something times log of something. Log of something times something. How about that? You got a rule that does log of multiplication?
Yeah.
Yeah, bust them into addition, right? So I got log of 2 to the 2 to the 83rd plus log of 2. All with me on that? Okay, now I can grab this stuff and pull it down front, right? So I got 2 raised to the 83rd times log of 2 plus log of 2. Somebody try to cram that crap in your calculator? Make sure you close this parenthesis when you do that.
What are you doing? Yeah, added 6 points now. Is that rounded?
Yeah, round.
6.70 times 10 to the 24th.
Cool. That's like big, right? And that's not A, right? That's log of A. So like that should be a lot smaller than A. Okay, if I take B and do the same trick, what am I going to get? If I take B and do the same trick, what am I going to get?
Log of 3 of 52
How about
times the log of 3.
3 to the 52, right? The top two pieces in your power stack times log of the middle one plus log of the bottom one. Okay, somebody hit that in the calculator quick. See what we get. What'd you get?
I haven't finished it yet.
7.098 e to the 24.
7.0 stuff.
98, yeah. Times e to the 24.
Times 10 to the 24. That's a capital E in there, right?
Yeah.
Yeah, so when the calculator puts capital E 24, what they mean is times 10 to the 24. So, which one's bigger?
E, that one.
B is. Same number of zeros, right? 24 zeros. And this one's got a 6.7, that one's got a 7.0, so the 7.0 wins it. B is bigger. How do I know B was actually bigger? Because I did some stuff, right? Like to get from A and B to those two numbers, I took log of everything. How do you know that logs keep the inequalities pointed the right direction?
Well, because it's just, as long as you do the same thing above.
Because if you multiply them both by -1, right, the inequality would flip direction. So what is it about functions? You apply a function to both sides of an inequality. When does it preserve the inequality? You guys remember?
When does it preserve the inequality?
Yeah, in other words, if you have this, right, if you have like x is bigger than y, right? If you do a function to both sides, like say f, then f of x is like somehow compared to f of y, right? When does it, like for which f does the inequality hold?
Does it inequality hold?
Yeah, so I want it to preserve the inequality. F needs to be, you guys know this?
When
F needs to be an increasing function. Strictly increasing function will preserve inequalities. Right, and that's because if you know that the inputs are x is less than y, The only way you're gonna know the outputs have f of x is less than f of y is if it's always going up. Right? Hence the increasing bit. So log is an increasing function, that's why you got away with doing this. Is cool with that? This question's hard.